Every smartphone, every artificial intelligence model, every cloud platform, every satellite, and nearly every modern electronic device shares one common origin. Not an office, not a laboratory, but a factory. Unlike traditional factories, this one does not shape steel, assemble automobiles, or manufacture furniture. Instead, it builds the tiny processors that power the digital world. Here, precision is measured in nanometers. Machines perform tasks beyond human capability, and microscopic imperfections can determine whether billions of calculations succeed or fail. This is more than manufacturing. It is one of the most sophisticated engineering environments humanity has ever created. Welcome to the semiconductor fabrication plant. Inside a semiconductor fabrication plant, the greatest enemy is almost invisible. Dust. A single particle, too small for the human eye to notice, can destroy an advanced processor worth thousands of dollars. That is why these facilities operate under extraordinary conditions. Air is continuously filtered. Temperature remains precisely controlled. Humidity is carefully regulated. Engineers wear specialized cleanroom suits, not to protect themselves, but to protect the chip. In this environment, success is measured not only by engineering, but by absolute precision. Because when building technology measured in nanometers, even the smallest imperfection becomes a major obstacle. Perhaps the most remarkable machines inside a fabrication plant never become consumer products. Their purpose is something far more important. They build the processors that power everything else. Using light, mirrors, vacuum systems, and astonishing engineering precision, these machines project circuit patterns so small they approach the physical limits of manufacturing. Every layer must align almost perfectly, again and again and again. Hundreds of manufacturing steps working together, transforming a polished silicon wafer into one of the most sophisticated products humanity has ever created. Long before artificial intelligence begins learning, its processors must first be born here. To many people, a semiconductor appears to be a single product. In reality, it is the result of an extraordinary journey. A silicon wafer enters the factory, then begins a manufacturing process involving hundreds of precisely controlled operations. Layers are deposited, patterns are projected, materials are etched, structures are inspected, defects are measured. The wafer returns to the process again and again. What seems like a simple chip may require months before it is finally complete. Every successful processor represents thousands of engineering decisions working together with extraordinary consistency. This is not mass production in the traditional sense. It is precision manufacturing, operating at the limits of modern science. Unlike many factories, a semiconductor fabrication plant cannot simply stop. Production continues, day and night, 24 hours a day. Hundreds of automated systems work in perfect coordination. Robotic vehicles move silicon wafers between processing stations. Sensors inspect microscopic defects. Artificial intelligence monitors equipment performance. engineers supervise an environment where even the smallest interruption can affect months of production. Because inside these facilities, time is measured differently. Every hour of downtime means thousands of unfinished processors, millions of delayed devices, and billions of calculations that will never happen. The factory never sleeps because the digital world never stops demanding more intelligence. Building a semiconductor fabrication plant is one of the largest industrial investments on Earth. Not millions of dollars, billions. Long before the first processor is produced, entire ecosystems must already exist. Reliable electricity, ultra-pure water, advanced chemical processing, precision manufacturing equipment, highly skilled engineers, secure logistics, research laboratories. Every part must operate with extraordinary consistency, because producing advanced semiconductors is not simply manufacturing. It is the coordination of thousands of technologies, working together with almost unimaginable precision. These factories do not become valuable because of their size. They become valuable because they produce the technology powering nearly every digital industry on Earth. Every breakthrough in artificial intelligence begins long before the first model is trained. It begins here, inside the fabrication plant. Before an AI system can answer a question, a processor must first exist. Before a robot can navigate, a processor must first exist. Before a satellite can communicate, a processor must first exist. The world often celebrates software, but software cannot exist without hardware, and hardware cannot exist without manufacturing. This is why semiconductor fabrication plants have become one of the most strategic industrial assets of the 21st century. They are not merely factories. They are the birthplace of the intelligence powering modern civilization. A semiconductor fabrication plant does not stand alone. Behind every cleanroom exists an entire ecosystem. Power stations deliver uninterrupted electricity. Water treatment facilities purify millions of liters every day. Chemical manufacturers produce materials with extraordinary precision. Fiber networks connect research laboratories across continents. Global logistics deliver thousands of specialized components exactly when they are needed. The factory may be the destination, but the infrastructure behind it is equally remarkable. This is how modern civilization advances, not through isolated inventions, but through interconnected systems supporting one another. Every advanced processor represents the work of an entire industrial network, operating almost invisibly. If semiconductor fabrication plants are so important, why doesn't every country build one? The answer extends far beyond money. These facilities require decades of accumulated expertise, thousands of highly specialized engineers, world-class research institutions, advanced manufacturing equipment, reliable infrastructure, and one resource that cannot be manufactured overnight: experience. Every generation of semiconductor technology builds upon the knowledge of the previous one. The ecosystem becomes more sophisticated. The engineering becomes more demanding. The margin for error becomes almost non-existent. Building a fabrication plant is difficult. Building the knowledge behind it is even harder. History often celebrates the technologies that people can see. the smartphone, the computer, the robot, the artificial intelligence assistant. Yet long before these innovations reach our hands, they begin in places few people will ever visit. Inside facilities where precision approaches perfection, where engineering becomes an art, and where the future is manufactured one microscopic layer at a time. The semiconductor fabrication plant is more than a factory. It is one of civilization's greatest achievements, a place where science, engineering, infrastructure, and human ingenuity converge. Because every intelligent machine, every connected device, and every digital breakthrough must first pass through these remarkable facilities. In the next episode, we leave the factory floor and follow the processors to their next destination, the hyperscale data center, the invisible engine that keeps the digital world running every second of every day. NEXNET, the architecture of modern civilization.